So if you did pick up a green packet for chapter 4, this is on pages 6 through 8. If you did not, well, it's still in the packet on pages 6 through 8. It just you won't be able to reference those. And I need to make sure to put the packet, I will do that today after class. I will put a PDF file of the packet in Schoology so you can access that if you would like to print your own. I know some of you prefer that. I just forgot to do that. Sorry about that. All right, so solving systems of equations by substitution. How do you use substitution to solve a system of linear equations? The concept is pretty straightforward. The process has in the past caused some problems for students, but I think we can get through this together. All right, so I will list this as a 5-step kind of process. So the first thing we need to do is get one of the equations solved for one of the variables. So we either want to have one of our equations as x equals something or y equals something. And if they're both that way, that's fine as well. The second step, we take whatever x was equal to or y was equal to in that first step and substitute or plug that in to the other equation. That's why it's called substitution. So then we would have one equation with just one variable. We then solve that equation to get the value for either x or y. And then take that value and plug it back into one of our original equations to find the value of the other variable. Just like with solving by graphing, our solution most of the time will be an ordered pair, a value for x and a value for y. And then we can check our solution to make sure it works for both equations. And again, we'll work through that together. All right, moving forward. So, solve the system of equations using substitution. Use substitution to solve each system of equations. So the first thing we're going to look at, if we're going to use substitution, do we have an equation in the form x equals or y equals given to us? So you can actually go to your I think if you go to participants, on the bottom there's a yes and a no that you could click on. So what do we have an x equals or a y equals equation in our system? Now let's see, this first equation says x equals. So the answer would be yes. So what we're going to do is in our second equation, instead of writing this x, we're going to substitute what x is equal to in the first equation. So we still have this 2, but instead of x, we're going to replace that or substitute negative 2y plus 4, because we were told from that first equation that that's what x is equal to. Finish writing out the rest of the second equation, plus 3y equals 1. And now we need to solve for y. So to solve this equation, my next step, distribute. Combine our like terms. Negative 4y plus 3y is negative 1y. Now get the y by itself. So undo any addition or subtraction. So I'm adding 8 to the y. I want to subtract 8 from both sides of my equation. So some people I know will draw a line like through their equal sign, just to make sure I'm subtracting 8 from both sides of that line. That keeps the equation equal. 1 minus 8 is negative 7. Now I undo the multiplying by negative 1. So I divide by negative 1. And y equals 7. That y looks pretty bad. So let me work on that a little bit. Okay. Now, don't stop there. That's half of your answer. Okay, so I'm going to just jump back for a second to the previous slide. So we had an equation solved for one of the variables. Step 1 was done. Step 2, substitute the expression or the equation from step 1. We did that. Solve that new equation. We did that. So now we're on step 4. Take that value we found and substitute into one of the original equations. So as I look at this, I can either take that 7 and plug it into the first equation or the second equation. And I'm going to give you a little bit of a hint. I think it's easier to substitute into the equation that's already solved for the other variable, so that we have this x equals. So to find my value for x, I think it's easier to plug 7 in for the y. So negative 2 times 7 times 7 plus 4, and solve. Negative 2 times 7 is negative 14 plus 4. So x would be negative 10. So our solution, negative 10, 7. One of the things I talked about during the first lesson is the great thing with solving systems, you can always check your answer. Excuse me. So we already know when we plug 7 into our first equation, we get -10. We don't really have to check that because we just did that work. But I'm going to plug 7 in for y and -10 in for x in this second equation just to make sure that my solution works. So I am going to take 2 times -10 plus 3 times 7 and see if that equals 1. And again, I like to put the question mark over the equal sign because I'm doing a check. I'm not sure that they're the same yet. If I multiply this out, -20 plus 21, does that equal 1? And 1 equals 1. It checks. This is a good solution. So a couple places that students kind of go wrong. Some students stop once they get the first value. Okay, so you need both an x and a y value. And then sometimes they forget to check their answers. So the reason I like checking my answer is I can now leave this problem and know I got it right. And so you should be able to tell when you're done with a problem whether or not you have the right answer, because your check should work if you've done it correctly. All right, let's take a look at the next example. 3x minus 8y equals 4, y equals 6x plus 7. So again, we have now our second equation is solved for y. So I can take 6x plus 7 and substitute that for y, because that is what y is equal to. So I take that first equation, I write everything the same except instead of y, I'm going to replace that with 6x plus 7, because that's what y is equal to. Now I'm going to solve for x. Again, to do that, I need to distribute. On this one, when you distribute, don't forget to distribute the negative. That's a big deal. I like to do things one step at a time. So when I'm solving an equation, I use the distributive property first, then I combine like terms. So here I have like terms, the 3x and the minus 48x gives me a total of minus 45x. Minus 56 equals 4. Then I undo any subtraction or addition. So here I've got subtraction of 56. I'm going to add 56 to both sides. And then undo multiplication or division. So I'm multiplying by negative 45. To undo that, I divide by negative 45. And I should reduce if I can. Is there a number that divides evenly into both 60 and negative 45? The answer is yes. Actually, 15 will divide into both. And let me just give you a little one way that you can check. Anytime a number ends in either 5 or 0, it's going to be divisible by 5. If you add the digits together, so like 6 plus 0, that's 6. If that sum is divisible by 3, the number is divisible by 3. So 60 is divisible by both 3 and 5. That's why 15 works. Same for 45. So I get -4/3. I'm a big fan of leaving it as a fraction, especially this one, because -4/3 you'd have, if you tried to write it as a decimal, it's a repeating decimal, and it makes it harder to check your answer. So now I need to find my y value. Again, I would plug into the second equation because it's already solved for y. You don't have to. You could certainly plug it into the first equation and that would work fine. You would just have to do one additional step. Um, 6 times -4/3. So you would do 6 times -4. Someone either shout out that answer, unmute yourself and shout it out, or put it in the chat. What is 6 times -4? I can wait. Excellent. Someone's deciding to chat. Oh, someone, for some reason, it didn't come up when I hit it. There it is. Yeah, all right. Several people put the right answer there. Excellent. -24. Then I need to divide by 3. So what is -24 divided by 3?
-8.
-8 is exactly right. And so, excuse me, 6 times -4/3 is -8. Then to finish the problem, I take -8 plus 7, and that gives me -1. So for this problem, my solution is -4/3, -1. And again, I want to check that. And I'm going to check that in the first equation because basically I've already done it in the second one. Now here's a great thing with fractions. 3 times -4/3. Because my whole number and my denominator are the same, they cancel each other out. -8 times -1 is +8. So I get 4 equals 4, and it checks out. All right. It's all right. Okay, so now we have for problem C, or example C, y equals 3x minus 10 and y equals 2x plus 5. In our original process, we said we want one equation in an x equals or y equals form. In this case, we have two, and that's okay. We can work with that. What we're going to do in this case is take the 3x minus 10 and substitute it in the y for the other equation. So basically, we're going to set both right-hand sides of the equation equal to each other. Okay. So this sets up a kind of a newer situation. Now we have variables on both sides of the equal sign. When that happens, what I like to do is I like to get my variables on the same side first. And, you know, Mr. Gingrich is getting kind of old, and he can't carry things that are heavy. It's bad for his back. So when I'm moving variables, I like to move the smaller number of variables. So I look at 3x, I look at 2x, and I say, 2x is smaller. So I'm going to subtract 2x from both sides. The other thing that's nice about moving the smaller number of variables is you always end up with a positive number in front of your variable. So 3 minus 2x is 1x. You don't have to write the 1. And over here, the 2x minus 2x, that cancels. Don't forget the negative that's in front of the 5, though. Now undo addition or subtraction. So I'm subtracting 10 from the x. To undo that, I add 10. Negative 5 plus 10 is positive 5, and 1x equals 5. Now I could divide by 1, but I know when I divide by 1, I get that number back. So x equals 5 is the first part of my solution. Now I take 5 and I plug it into one of my two original equations. And in this case, it doesn't matter which one you choose. So let's, I'll put it up to a vote. Should I plug it into the first one or the second one? The first one, perfect. And the other thing is, when I check my solution now, I'll just use the second equation. So whichever one you chose for this, you would use the other one for your check. 3 times 5 is 15. 15 minus 10 is 5. So our solution looks like it's going to be the 0.55. Double check that by using the second equation. 5 equals 2 times 5 minus 5. So my check, 5, does that equal 10 minus 5? 5 equals 5 is a good answer. My answer checks out. All right. So far, so good. So with graphing, there were two kind of special cases. One where we got infinitely many solutions because the lines sat one right on top of the other. When we're solving using substitution, we can get that identity like 2 equals 2. And that means we're going to have infinitely many solutions. So if you get a number is equal to itself, infinitely many solutions. If you get a false statement, a number is equal to a different number, that means we have no solutions. So that would be the case where our lines were parallel in our solving by graphing. So we still have those possibilities. They're just going to look a little bit different. So a number equals itself, infinitely many solutions. A number equals a different number, no solutions. Okay. So again, we're going to use substitution and solve. So my second equation is in that x equals form. So I'm going to take what x is equal to and plug it in for x in the first equation. So 4 times negative 2y plus 1 plus 8y equals negative 8. Distribute the 4. So negative 8y plus 4 plus 8y equals negative 8. Combine my like terms. So negative 8y plus 8y, 0. So I get 4 equals negative 8. That statement is never true. So this would be a case where we would have no solution. In other words, there is no ordered pair xy that makes both equations true. If we graph those two lines, we would have parallel lines. They would never intersect. So no solution and infinitely many solution actually are less work. You usually get those answers in that first couple steps. Same thing here, using substitution. Y equals 3x plus 1. 6x minus 2y equals negative 2. So I'm going to take the 3x plus 1, substitute that in for y. Everything else in the in that second equation stays the same. Distribute. So I have 6x. And remember, I'm distributing negative 2 here. So I get minus 6x minus 2 equals negative 2. 6x minus 6x, 0. So negative 2 equals negative 2. That is always true. So if we get something that's always true, we have infinitely many solutions. In other words, if I picked a value for x and plugged it into my top equation and got a value for y, it doesn't matter what x value I picked, I would get a y value, and that ordered pair, that xy combination, would also make the second equation true. And again, graphically, if I graphed both of those equations, they would be the same line. All right, so what I would like you to do is try this system. Actually, there are two of them, but whoops, sorry. There we go. So what I'll do is I'm going to split the screen so you can see both. And I want you to work on those. And if you have questions, go to the chat. Go ahead and ask, and I'll try to answer them through the chat. So that you can continue working. Excuse me. So solve each system using substitution. Write no solution or infinitely many solutions where appropriate. It's not necessarily going to be a no solution or infinitely many. So if you solve it and you get a value for x and a value for y, that's great. So that would be your solution. I'm going to give you 5 minutes to try these two. And then we will come back and take a look. So in just a moment, I will start the timer and mute myself so you don't have to listen to my raspy voice. And then in 5 minutes, and what I would like you to do is go in the chat when you've got your solutions and just let me know. One is either the ordered pair that make it true, or no solution, or infinitely many solutions. And then 2 is, and just go ahead and put those in the chat. It's a great way for me to see where we're at. All right, I am going to mute and stop my video. Hi, Jacinta.
Hello.
So when you which are you working on, the first problem or the second one? Or is it
We're gonna
just
work on the first one.
okay?
Huh?
So, go ahead.
Oh. Okay, so I'm stuck on how to like distribute again because I haven't did it in a while.
Okay.
So I just need clarification on how to do it.
Yep, it's just multiplication, right? So
Okay, just want the.
yep. So like that first one, when you plug in the 3y minus 9 for x, you're going to take the 4 and multiply by 3y, and the 4 times the minus 9.
Okay.
Okay.
Okay. Yeah.
Terrific. Then you, if that's all you need, I thought maybe talking about it in a breakout room would work a little bit easier.
Mm-hmm.
All right. Does that work out good? Okay, good.
Yeah,
Good.
thank you. Thank
All
you
right.
so much.
You are welcome. All right. See you back in the main room.
All right.
So we get 12y minus 36 minus 2y equals negative 6. I would combine my like terms, the minus 2y and the 12y. So that would give me 10y. And then add 36 to both sides. 10y equals 30. Divide by 10. Y equals 3. To check my x value, I take that 3 and I'm going to plug into that first equation. It said y was equal to 3. So x is equal to 9 minus 9. That would mean x is 0. Now, for some reason, students tend to freak out when they get 0. 0 is a great answer. There is absolutely nothing wrong with having 0 for an answer. That's one of the answers that students don't like, but it's an okay answer. The other one is when they get a fractional answer like we got on one of our earlier examples. Fractions are okay. I do want to double check that that answer works in my second equation. So 4 times 0 minus 2 times 3, is that equal to negative 6? Oh boy, tough stuff here to start with. 4 times 0. I'm pretty sure that's 0. Minus 2 times 3 is minus 6. And negative 6 does indeed equal negative 6. It checks. So my solution is good. Okay. Excuse me. For my second example, for the second try now, I'll take what y is equal to in the second equation, plug it into the first, minus 3x plus 3 times whatever y is equal to, in this case, x plus 9, equals 27. I am going to distribute or multiply by 3 on the second part of that equation. Negative 3x plus 3x plus 27. Negative 3x plus 3x, that's 0. So combining my like terms, I get 27 equals 27. That is always true. So we get infinitely many solutions. So you just want to be careful with the a problem like this. Make sure you multiply that 3 all the way through. If you don't, if you just multiplied it by the x, it would look like you'd maybe have no solutions, but this one does indeed have infinitely many. So just be careful with that. All right. One last question. If I gave you this system of equations, 6x minus 5y equals -1, and 6x plus 4y equals -10, would that be a good system to solve using substitution? Why or why not? In order to use substitution, what's the one thing we need from one of our equations?
It doesn't have like a x or a y.
Right, right. So in this case, it's not an x equals or a y equals. So I probably wouldn't choose substitution. So would you want, you could, but I'm going to say no, because we do not have an equation that is x equals or y equals. Now, could we use substitution? Yes, we would just need to solve one of those two equations for either x or y, and it does take a little bit of work. The great news is next week, we'll look at systems of equations that look exactly like that and use another way to solve them. I can tell you're just all excited about that.